So welcome students. Let's continue with our second session on mechanics of structure. As you are following 2019 pattern under SPPU, that is Savitribai Phule Pune University. So we'll just revise quickly. We have seen the syllabus of MOS, that is mechanics of structure, in which we have total 6 units: simple stress and strains, SFD and BMD, bending and shear stresses, torsion and principal stresses, columns, and slope and deflection, in which the subject is divided into 2 segments, that is 30 marks in semester examination on 2 units and end sem of 70 marks on 4 units, along with oral examination of 50 marks on experiments. And we have also seen the prerequisites in previous session, which includes types of forces, resolution and composition, support reactions, and types of beam. So in types of forces, there are 3 force systems: collinear, concurrent, and parallel. Under loading, we have concentrated load, UDL, and UVL. Along with that, we have clockwise and anti-clockwise movement with couple. So this is our collinear force system, concurrent force system, and parallel force system. We already discussed all these things in previous session. Now coming to loads, concentrated load or point load means the load which acts at a single point. Then UDL, the total load is distributed along the length. Then UVL, the intensity varies uniformly. You can observe from extreme left or extreme right, means from the support to the middle, it is uniformly varying. So UVL, then we have moment, that is clockwise moment and anti-clockwise moment. So moment is nothing but a rotational effect. Then we also seen the couple, means when 2 equal and opposite forces acts together, it forms a couple, means a rotational effect in which 2 equal and opposite forces are involved. And then we also seen resolution and composition. So what is resolution? Representation of single force into number of components. And what is composition? Opposite to resolution, we have composition, that means representation of number of forces into single force. म्हणजे एका फोर्सचे तुकडे केले, इट इज रिझोल्युशन, आणि सगळ्या फोर्सेस मधून एक रिझल्टंट काढला, इट इज कंपोजिशन. Then we also seen the important thing, that is support reactions, in which we have types of support and number of reactions. So basically we have 3 supports: roller support, hinge support, and fixed support. So for roller support, we have one reaction that is perpendicular to the plane of rollers. For hinge support, it is also called as pin support. We have 2 reactions, one vertical, one horizontal. And in case of fixed support, we have 3 reactions, 2 forces and 1 moment. So vertical reaction, horizontal reaction, and a moment in case of fixed support. And at last, we have seen types of beams, which includes cantilever, simply supported, continuous, overhang, fixed beam, and propped cantilever. So this was about the quick revision of the prerequisite things which are required to understand the mechanics of structure, which was previously known as strength of materials. Means we are studying, or will be studying, all the properties and things related to the material specifically, right? So along with that, we also seen 1 or 2 examples, in which first example was dealing with cantilever. So we have drawn the free body diagram at first, and we have identified as it is cantilever beam, means fixed support was provided. So total 3 reactions are developed: 1 vertical reaction, one horizontal reaction, and one moment. As three unknowns are present, so three equations are required. So we have used three equations of equilibrium, means conditions of equilibrium, and those are summation fx equal to 0, right, means summation of horizontal forces, summation fy equal to 0 means summation of vertical forces, and summation moment equal to 0 means summation of moments, right? So from that we have got horizontal HA as no force was present in a horizontal direction, therefore HA was 0. Vertical forces were present, so we have got the value of VA as 8, and these three forces contributing or creating a rotational effect on the support. So that rotational effect, its reaction means your moment about point A, that was again 20 kilonewton meter. And similarly we also seen second example, means support reactions of simply supported beam. Again it is simply supported beam, means one side we have hinge support, another side we have roller support, but as no horizontal force is present, means no horizontal external force is present, so horizontal reaction is absent, therefore we have only two unknowns, means two reactions, that is VA and VE. So two unknowns means we need two equations. So whenever you require two unknowns, means when two unknowns are present, but we have total three equations, summation fx, summation fy, and summation moment. When horizontal force is absent, you have only two vertical reactions as unknown thing. So we have two equations, summation fy and summation moment. So always start with a moment, because if you observe the second expression, that is summation of fy, you can observe the expression. In that expression two unknowns are present, means ra and re, right? So we have only single expression. If you are solving summation fy equal to 0, in that expression we are getting two unknowns, so we cannot solve, or we cannot have one value, means ra or re, from this single expression, as it has two unknowns in it. Therefore it is required to go for additional expression. Therefore always keep in mind that when we have only two unknowns, always start with moment expression first, means summation of moment equal to 0. By using summation of moment equal to 0, we can have the answer of one unknown between those two, and once you have the value of first unknown, you can put that value in the second expression of summation fy, from which we can have, or we can solve, or we can get the answer of the second unknown. Okay, so always remember, when we have two unknowns, start with moment expression at first to calculate the support reaction, and then use that answer of first unknown into second expression of summation fy. So this was about our prerequisites. So let's see some brain twist, means one short puzzle or few brain twists are there for you. So let us see. So the question is, identify the type of material. Identify the type of material. There are only two categories, brittle or ductile. As I already told you that mechanics of structure was previously or formerly known as strength of materials. Means in MOS we are studying all the properties, effects on materials. So we must understand the material, and those materials specifically related to civil engineering, right? And these materials are categorized into only two categories, that is brittle material and ductile material. So every one of you or each one must be knowing what is brittle material and ductile material, right? So let's have a look. So the first question is timber. Timber means wood. So identify whether timber is a brittle material or ductile material. Anyone can answer.
Brittle.
Timber is a brittle material. बघा बरं, आन्सर फक्त सांभाळून द्या. फक्त जे मनात येते ते सांगायचं, पण थोडं विचार करून सांगायचं. फर्स्ट आन्सर इज timber is a brittle material. Whether anyone is thinking in other direction, whether it is ductile. बघा बरं, तुम्हाला फिजिक्सचं आठवायचं आहे थोडस. व्हॉट इज डक्टिलिटी अँड व्हॉट इज ब्रिटलनेस. ओके, विल प्रोसीड. So the answer for first question is brittle material. Means your answer was correct or your answer is correct. हे इझी आहे, ठीक आहे. आता आपण थोडीशी कॉम्प्लेक्सिटी वाढूया. सेकंड, टाईल. कोणी पण आन्सर द्या, तसं काही नाही. बरं, टाईल. आता दीपक म्हणतोय टाईल इज अ ब्रिटल मटेरियल. बरं, आदित्यला काय वाटतं? आदित्य, व्हॉट डू यू थिंक? आदित्य अँड स्वप्नील. आवाज नाही आला आदित्य.
डक्टाइल.
Okay, Aditya is thinking tile is a ductile material. Swapnil? Swapnil, what do you think? आणि बोलून मोकळं व्हायचं, जास्त वेळ पण लावायचं नाही. जे आहे ते आन्सर सांगून मोकळं व्हायचं. जास्तीत जास्त काय होईल, एकटा आपलं बरोबर असेल किंवा चुकीचं असेल, काय विचार करायचा नाही. वी आर हिअर टू लर्निंग और वी आर हिअर टू लर्न. हा, स्वप्नील, व्हॉट डू यू थिंक? ब्रिटल और डक्टाइल? आवाज नाही येत आहे. Okay. Aditya is thinking it is ductile material and Deepak is saying it is brittle material. So the answer is brittle material. रिझन मी नंतर सांगणार, म्हणजे जे तुम्हाला लक्षात ठेवायचं आहे कन्सेप्ट, तो मी शेवटी सांगणार आहे. नेक्स्ट, थर्ड पॉइंट, ब्रिक्स. हा, अमेय आणि अनिशा.
ब्रिटल सर.
बरं, प्रेम अँड दीपक बोथ आर सेइंग ब्रिक्स इज अ ब्रिटल मटेरियल. अनिशा अँड अमेय.
सॉरी सर.
हा, सौमित्र.
ब्रिटल ब्रिटल.
ओके, अमेय म्हणते ब्रिटल.
नो सर, अनिशा.
ओके, अच्छा, अनिशा म्हणते ब्रिटल. सो ब्रिक्स इज अ ब्रिटल मटेरियल. ओके, that is again correct answer. Next, chalk.
ब्रिटल.
Chalk is a brittle material. बरं, बघूया करेक्ट आहे का. Chalk is a brittle material. Then moving further, glass. आता बघूया. Glass. Okay, Deepak is saying glass is a ductile material. And other students?
Ductile, sir.
Yash is saying ductile. Anyone? राजला पण वाटते डक्टाईल. बघा, कॉम्प्लिकेशन आहे, कॉम्प्लिकेशन आहे. ठीक आहे. नाउ लेट अस सी द आन्सर. आन्सर इज ब्रिटल मटेरियल. ठीक आहे, पहिले सगळं होऊ द्या, नंतर मी सांगतो. नेक्स्ट, स्टील.
डक्टाइल सर.
Steel is a ductile material.
Ductile, sir.
Okay, all are in a favor of ductile. ठीक है.
Yes, sir.
Steel is a ductile material. Then brass.
Ductile.
बघा, सगळे डक्टाईलच्या मागे जाऊ नका बरं, विचार करून आन्सर द्या. ब्रास. फर्स्ट आन्सर इज डक्टाइल मटेरियल.
Ductile.
Okay, we'll see the answer. Brass is a brittle material. And last, aluminium.
Ductile.
Ductile.
Ductile. Okay, we'll see the answer. Aluminium is a ductile material, right? So among all these 1 2 3 4 8 questions, Many of us have answered in correct direction, means whether that material is brittle or ductile. आता विचार कसा करायचा, लक्षात कसं ठेवायचं ते मी सांगतो. थिंकिंग अबाउट टिंबर, काय फक्त लक्षात ठेवायचं, टिंबरच्या आपण चॉकनी सुरुवात करूया. चॉक हातामध्ये पकडलाय तुम्ही, तो वरनं खाली सोडला. What will happen to the chalk? As soon as it falls on the ground or on the floor, it breaks. ठीक आहे, पडल्या पडल्या तो तुटणार आहे. तो बेंड होणार आहे का नाही, तुटणार आहे म्हणजे काय, लगेच तुटत असेल इट इज ब्रिटल मटेरियल. आणि जर तो लगेच तुटत नसेल इट इज डक्टाइल मटेरियल. बेंड होत असेल तर डक्टाइल मटेरियल, तुटत असेल डायरेक्ट तर ब्रिटल मटेरियल. वी स्टार्ट विथ टिंबर. वेन वी आर कन्सिडरिंग टिंबर, टिंबर म्हणजे लाकूड, वूड. When you try to bend the timber, it bends to some extent, but it breaks suddenly. डायरेक्ट त्याचे दोन तुकडे होतात. तुम्ही त्याला यू शेप मध्ये बेंड करू शकत नाही टिंबरला. As you try to bend it into U shape, it will break into two pieces. So timber is a brittle material. Then tile means your flooring tile. Flooring tile तुम्ही वरनं खाली सोडली, as soon as it falls, it will break. So tile is again brittle material. Then bricks, it's very easy question. Brick is a brittle material. On similar ground, chalk is a brittle material. Now aluminium. Aluminium is a ductile material because it bends. लवकर तुटत नाही aluminium, तो bend जास्त होतो. Therefore aluminium is a ductile material. Then moving to brass. Brass म्हणजे पितळ. इट इज ब्रिटल मटेरियल. तुम्हाला असं वाटेल की मटेरियल अल्युमिनियम पण डक्टाइल आहे, ब्रास पण डक्टाइल असू शकतं. बट वेन वी टेस्ट द ब्रास इन आवर एक्सपेरिमेंटल लॅबोरेटरी, वी हॅव और वी कॅन ऑब्झर्व द फेल्युअर ॲज इट ब्रेक्स सडनली. ब्रास सडनली तुटला म्हणजे काय, इट इज अ ब्रिटल फेल्युअर, नॉट द डक्टाइल फेल्युअर. नाउ मूव्हिंग टू स्टील. स्टीलचा बार, स्टील म्हणजे आपलं स्टीलचं पातेलं नाही, स्टीलचा बार. So it is a ductile material because it bends to very much extent, right? And then it fails. Therefore it comes under ductile nature. And at last the question was glass. Identify glass, whether it is brittle material or ductile material. आता ग्लास जेव्हा तुम्ही मटेरियल म्हटलं, क्वेश्चन जेव्हा आला ग्लास, तर तुमचा पहिला क्वेश्चन असा हवा होता की सर पाणी प्यायचा ग्लास आहे की गाडीचा काच आहे. ओके, तो तुमच्याकडून क्वेश्चन आलेला नाही. ठीक आहे, त्यामुळे कुठला जरी क्वेश्चन आला, पहिले त्याच्या मागची गुगली चेक करायची, वेदर इट इज अ गुगली क्वेश्चन और सिंपल क्वेश्चन. ऍज सून ऍज ग्लास वॉज रिफ्लेक्टेड, पहिली तुमच्या डोक्यामध्ये स्पार्क काय झाला पाहिजे की हा स्टीलचा ग्लास आहे पाणी प्यायचा की गाडीचा काच आहे. सो थिंकिंग इन अ वे दॅट इट इज ग्लास मीन्स मटेरियल, गाडीचा काच आहे असं आपण कन्सिडर केलंय. सो गाडीचा जो ग्लास आहे त्याला लॅमिनेशन केलेलं असतं, त्यामुळे तो बेंड होतो पण तुटत नाही. पण तुम्हाला इमॅजिन काय करायचंय, जो प्लेन आरसा असतो आपला काचेचा आरसा, काच, that काच is nothing but your glass. So as you drop the glass from any height, it will break at the moment or in a moment. Suddenly it will break. Therefore it is brittle material, not the ductile material. म्हणजे लक्षात तुम्हाला काय ठेवायचंय, बेंड जर होत असेल, तुटत नसेल लवकर, इट इज डक्टाइल. बेंड झाला पण लगेच तुटतोय, इट इज ब्रिटल मटेरियल, राईट? सो दिस वॉज अबाउट अवर फर्स्ट क्वेश्चनियर. नाउ one extra thing is for you, that is, okay, so we'll move to the second segment, that is around the world. So few things I have collected for you. So in today's session we have most expensive materials in the world. It is specifically top 10 materials I have collected for you, that is most expensive materials. Some of you must be knowing all these materials, but many of you will not be knowing. So let us explore. So at number 10 we have gold. During this COVID situation, the price of gold has rose to 50,000, means around 5,000 per gram, but in normal stages it was having 30,000 rate for 10 grams, so 3,000 per gram. So it is most well known or precious metal at number 10. सगळ्यांच्या लिस्ट मध्ये तो 10 नंबरला असतो, सगळ्यांच्या लिस्ट मध्ये तो 1 नंबरला असतो, सगळ्यात महाग आहे गोल्ड. पण या लिस्ट मध्ये तो 10 नंबरला आहे. At number 9, rhodium. Let's check its price. That is 3,800. At number 9 we have rhodium. Then number 8, platinum. Then at number 7 we have plutonium, 2,70,000. Then at number 6 we have pynite, 6 lakhs per gram. And at number 5 we have taphite, 13 lakhs. Then tritium,
20 लाख पर ग्राम.
फक्त यश माईक बंद कर तुझा, सगळ्यांना ऐकू येतंय. Then at number 3 we have diamond, original diamond we are talking about. Then number 2 we have californium. आता मी फक्त अमाउंट वाचत नाही, तुम्ही वाचा. And at number 1 we have antimatter. ज्यांना सायन्स मध्ये स्पेस मध्ये इंटरेस्ट आहे त्यांना नक्कीच माहिती असेल व्हॉट antimatter is. So this was about the most expensive materials. So let's proceed to our main thing, that is mechanics of structure. So before proceeding, let's have a look on a short video on materials. So let me share it.
To building materials. At the end of this lesson, you will be able to define building materials, classify the types of building materials, correlate the performance and selection criteria of building materials. Almost everybody who wishes to settle in their life dream of building their own home. An average person spends half of his earnings in building his own house. In this process, some succeed while others do not. This is due to the cost of construction, especially in buying construction materials. Selecting the right construction materials is one of the toughest tasks of a construction engineer. Hence, he or she has to know the classification, performance and economics of the building materials. Only by being aware of this, an engineer can use the construction materials in a sustainable manner. As a future engineer, are you ready to learn about this? Come on, let us dive in to learn the common building materials in detail. Building materials are the materials that are used to construct any civil structure. With the help of these materials, several civil structures are constructed such as buildings, dams, skyscrapers, towers, etc. These building materials are broadly classified into two main categories. They are natural building materials and artificial building materials. First, let us learn about natural building materials. The building materials that are available naturally are known as natural building materials. Some of the common examples are mud, stone, sand, wood, leaves, lime and fibers. Mud. In the early stages, when people started to build houses, mud was one of the first materials they preferred. People used the mud along with cow dung and chopped straw to build the walls of their houses. Still, this concept of construction is used in the wall cladding and flooring of modern construction. Moreover, the combination of mud and cement provides excellent durability to the finishing surface. Another important construction material is stone. It is in use since ancient times. It is widely used in different components of a building such as walls, floors, foundations, roofs, etc. Usually, stones are obtained from natural quarries and are processed to put into use. Some of the stones commonly used today are granite, marble, sandstone, limestone, etc. Sand. With the effect of rock disintegration, small grains of silica are produced subsequently to form sand. The source of sand for construction is usually pits and rivers. Sand is used to create many building materials such as concrete, mortars, plasters, etc. Wood. Nature's most abundant material, wood, is one of the most important building materials in all periods. The main source of wood are deodar, teak, and bamboo trees. People use the wood mainly for the construction of windows, doors, ceiling, roofing, etc. Leaves. With the help of the leaves, people construct a temporary roof structure in their houses. Palm, palmyra, and coconut trees are the major source of leaves for construction. Lime. Due to its various benefits, lime is nicknamed as nature's cement. From ancient ages, lime has been used in various constructions such as palaces, monuments, temples, bridges, etc. Though lime got replaced by cement in most of the areas, it continued to serve in areas that were economically weak. In building constructions, they are used as a damp-proofing material in floors and roofs. Fibers. Since ancient days, various types of fibers have been used in construction. Some of the major sources are coconut husk, jute fiber, banana leaves, etc. Some of the commonly used fibers in building construction are coir fiber, sisal fiber, bamboo fiber, etc. The main uses of fibers are they arrest the growth of cracks when used in reinforced cement concrete. They are also used to improve the soil properties. Performance and economics of natural building materials. Most of the natural building materials have a good durability due to their natural origin. Apart from that, they are easily accessible to repair and maintain a stable temperature irrespective of the seasons. Since such materials are naturally available, natural building materials are very cheap when compared to the artificial building materials. But they soon started becoming extinct, which paved the way for mankind to invent artificial building materials. Now, let us discuss about the artificial building materials. The materials that undergo human processing are known as artificial building materials or man-made materials. Some of the examples are cement, brick, tiles, glass, metal, plastics, etc. Let us now discuss them one by one. Cement. Cement is widely used in constructions today for its strength and durability. It has the ability to bind together with loose particles such as gravel and broken stones. One of the main features of cement is its quick setting properties, which in turn made it the most famous building material. They are used in the construction of literally all the civil structures. Bricks. Another most extensively used material, brick is made up of kiln-fired materials like clay. Good insulation property against sound and heat is the most important quality of brick. Moreover, we can attain several shapes and sizes in bricks through molding. Tiles. Tiles are produced using hard-wearing materials like ceramics. Based on the application, the tiles are classified into two types. They are common tiles and encaustic tiles. Tiles that are used for paving, flooring, and roofing are common tiles, whereas the tiles that are used for decorative purposes is known as encaustic tiles. Some of the examples of tiles are roof tiles, pot tiles, and floor tiles. Glass. Glass is manufactured by heating soda, lime, and sand. Glass is widely used as a construction material for glazing doors and windows in the form of tempered glass. Tempered glass is produced by heating a glass plate followed by a sudden cooling process. Moreover, glass is further used for soundproof partitions. Metal. One of the important backbones of all the construction products is metal and its subproducts. Metal is used as a construction material in two forms, which are ferrous metals and non-ferrous metals. Ferrous metals consist of iron and steel, while the non-ferrous metals consist of aluminium, copper, and zinc. The most generic example is steel rods, which is commonly used in reinforced cement concrete. Aluminium is used along with glass in facade type of constructions, which we commonly see in all the modern skyscrapers. Plastics. We can say plastic is the most important versatile material in today's constructions. Based on the requirements, plastics are available in various forms such as switchboard, tap and domestic furniture. Performance and economics of artificial building materials. Most of the artificial building materials have a good sensitivity as they are designed manually. Some materials like cement and metals have good durability with shear strength. Also, they can be molded to any shape as per the needs. When compared to natural materials, they are little expensive and require proper knowledge before buying and putting it into use. Some of the factors to be considered while selecting the building materials are utility, durability, availability, ease of maintenance, and cost. Summary. This brings us to
So this was about the building materials. So let's move to our first unit, that is simple stresses and strains. So first we'll take a look on the course objective and the outcome. The objective of this unit is to study the various types of stresses for determinate structural members, and the outcome that you would be able to understand the concept of stresses and strains with different types of stresses and strains in determinate, indeterminate, homogeneous, and composite structures. So first we'll see the theoretical concepts related to our first unit, that is simple stresses and strains. So as a first part, we need to study the types of material. So we have elastic, plastic, and rigid. So what is elastic material? Anyone can answer. What is elastic material?
Sir, the substance which can retain its shape.
Yes, correct answer. The material which regains its original shape and size after removal of external load. The material which regains its original shape and size after removal of external load is called as elastic material, or it is termed as elastic material. For example, steel, rubber, etc. Now what is plastic? The material which does not regain its original shape and size after removal of external load. महत्वाचा पॉइंट काय आहे, की एस्पेक्ट तुम्हाला लक्षात ठेवण्यासाठी, इट इज रिमूव्हिंग द एक्सटर्नल लोड. द मटेरियल विच रिगेन्स, it is elastic. Which does not regain, it is plastic. And what is rigid material? Rigid material is a material which does not deform, right? So moving further, again a small question for you. Which is the most elastic material amongst the following five? Which is the most elastic material? So let's see the 5 materials. First one is timber, then plastic, then rubber, steel, and aluminum. Think properly, think for a minute, and then you can answer. Which is the most elastic material? Sahil is saying rubber. बाकीच्यांना काय वाटतंय? सगळ्यांनी आन्सर द्या.
Aluminium.
Aluminium. दीपक म्हणतो aluminium. Again,
Steel, sir.
Saumitra is saying steel. We have got 3 different answers. Again, okay, we'll go one by one. Whether timber is elastic material?
No, sir. It's
No.
brittle.
Okay, it
No,
is
sir.
brittle material. We'll remove the timber. Then think about plastic. Whether plastic is elastic material?
No, sir.
No. Okay,
sir.
that is also gone.
No.
Now rubber is elastic material.
Yes.
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 Steel is elastic material.
Yes.
Aluminum is elastic material.
Yes.
Yes.
But the question is, which is the most elastic material? Now we have 3 options: rubber, steel, and aluminum.
Rubber.
Which is the
Rubber.
most
Rubber.
elastic material? Okay, so most of you
Rubber.
are saying rubber. Correct? So rubber is the correct answer. Rubber is a wrong answer. सगळे काय विचार करणार आहे? रबर इमॅजिन केला, एक इरेझर असेल किंवा कुठलाही रबर, आपण त्याला ताणू शकतो. वी कॅन पुल द रबर अँड वी कॅन बेंड द रबर ऑल्सो. म्हणून सगळे काय विचार करतात की रबर इलास्टिक मटेरियल आहे. बट रबर पेक्षा पण चांगलं म्हणजे जास्त इलास्टिक मटेरियल इज स्टील. त्याच्यामुळे स्टील आपण आरसीसी मध्ये वापरतो कन्स्ट्रक्शन करण्यासाठी. अदरवाइज इन्स्टेड ऑफ स्टील बार्स आपण रबर तिथे ठेवला असता. ठीक आहे. So we have different materials and all the materials are tested in laboratory and we have found that though rubber is an elastic material but its strength is less or its ductility is less as compared to steel. मग सगळे मेंबर किंवा सगळे मटेरियल जेव्हा टेस्ट केले लॅब मध्ये, जे आपले सायंटिस्ट वगैरे होते एक्सपेरिमेंटेशन करणारे, they have found that steel is very much ductile material than the rubber one. ठीक आहे. त्यामुळे त्यांनी काय डिसिजन घेतलं की रबर तुम्हाला दिसणार. परत मी तुम्हाला काय सांगितलं होतं की क्वेश्चन वाचताना गुगली क्वेश्चन आहे का चेक करायचं अगोदर. सो दिस वॉज द गुगली क्वेश्चन बिकॉज इन जनरलाइज व्ह्यू तुमचा असेल एखाद्याचा कुणाचा जनरल पर्पज म्हणजे जनरल पीपल व्हॉट दे विल थिंक, दे विल गो बिहाइंड रबर. बट ऑलवेज कीप इन माइंड बिंग अ सिव्हिल इंजिनियर, कारण की आता तुम्ही सिव्हिलला आलेलेच आहात, सिव्हिल इंजिनियर तुम्ही झाल्यासारखेच आहात, असाच इमॅजिन करा. And always keep in mind that among different materials steel is the most elastic material. हा क्वेश्चन तुम्हाला ओरल मध्ये पण कोणी ना कोणी कुठे ना कुठे विचारणारच आहे. ठीक आहे. सो करेक्ट आन्सर इज स्टील. Okay, so let's move. So as the former name or earlier mechanism of structure was called as strength of materials, so we must understand the strength or what is meant by strength. So let us see. So what we need to understand is when a load acts on a material. Read the statement properly and try to understand the concept. When a load acts on a material, it offers a resistance, right? Everybody knows Newton's third law. For every action, there is equal and opposite reaction. So when a load acts on a material, it offers a resistance. This is our first statement. So this resistance is continued till the deformation starts. Now what is deformation? When we have a simple bar किंवा कुठलं एक मटेरियल घ्या, त्याचा जो शेप अँड साइज आहे, बिफोर ऍप्लिकेशन ऑफ लोड it will not deform, right? Or it will not displace. So when load acts on a material, it offers a resistance. लोड तुम्ही जसा जसा वाढवणार तसं रेजिस्टन्स त्याचं वाढत जाईल, म्हणजेच काय त्याची रिएक्शन वाढत जाईल. मग ते कुठपर्यंत चालणार आहे? टिल द डिफॉर्मेशन स्टार्ट्स. त्या मटेरियलचा शेप जोपर्यंत चेंज होत नाही, शेप झालं, साईज झालं, हे जोपर्यंत चेंज होत नाही तोपर्यंत तुमचा रेजिस्टन्स चालू राहतो. राईट. सो द रेजिस्टन्स इज कंटिन्यूड टिल द डिफॉर्मेशन स्टार्ट्स. Right. So what is the strength? The maximum load carried by the material before the deformation is called as its strength. समझते point? When load acts on a material, due to Newton's third law, it offers a resistance, which you call it as reaction. This resistance is continued till the deformation starts. Now what is deformation? When there is change in shape and size of the material. जोपर्यंत ते डिफॉर्मेशन होत नाही तोपर्यंत रेजिस्टन्स तुमचा चालू राहणारच आहे. हेन्स व्हॉट इज स्ट्रेंथ? द मॅक्सिमम लोड कॅरीड बाय द मटेरियल बिफोर द डिफॉर्मेशन is called as its strength. Now we have three different statements. याच्यामधलं एक सिंपल समरीचं स्टेटमेंट्स आहे. सो इन शॉर्ट, strength means capacity of resistance. If you need detailed statements, keep first three statements in your mind, and when you need to understand the concept or you want to remember the thing, that is what is strength, remember fourth line. So strength means capacity of resistance. त्याची capacity संपली, the material will deform or material will displace. मग ती कॅपॅसिटी काहीतरी असणार आहे. ते कॅपॅसिटी पर्यंत जेवढी तो लोड घेणार आहे की the resistance it is going to offer, that capacity or resistance is called as strength. Clear? So this was about strength. So let's move to stresses and strains. So first unit is simple stresses and strain. So we must understand what the stress is and what the strain is. So what is stress? The internal resistance per unit cross sectional area. What is stress? The internal resistance per unit cross sectional area is called as stress. Means internal resistance against deformation. What you need to keep in mind is stress means internal resistance against deformation. Capacity of resistance is strength. Resistance against deformation is stress. Right? So first we'll understand what the stress is. So observe the first image, means upper one. What is shown in the first image? A bar which is highlighted with green color is subjected to two forces, P to the left hand side and P to the right hand side. The nature of the force is, nature means tension and compression. So as this force P is pulling the green block or green bar to the left hand side, means away from the body, and also on the right hand side it is away from the body, means from both the ends force P is pulling the object or pulling the bar, means the object or block or bar is subjected to tensile force of magnitude P. Right? Now focus on second image, the middle one. Now we have drawn an imaginary section which is highlighted with black line. A vertical section is drawn, and due to the section the green bar is cut into two pieces, the second image and the third image. Right? First focus on the second image. So when we are cutting the bar into two pieces, the section line, right, म्हणजे होते का नेमकं बघा, पीस तुमचा कट केलाय, initially the section line which was absent, the force P is pulling the block or pulling the object with a tensile nature or tensile force, right? Ata, we have a concept or a term which is called as equilibrium, correct? What is equilibrium? Equilibrium means a stable condition. कसं लक्षात ठेवायचं? Equilibrium means a stable condition. So initially the block is in equilibrium. When we have applied two forces, equal and opposite forces, still our block is in equilibrium. Means after cutting also through the imaginary plane or section, the half segment or half section will try to maintain the equilibrium, right? So though left P force is acting to the left hand side to maintain or to balance the equilibrium, this section line will offer the equal and opposite force, which is denoted by capital R and highlighted with blue color. Now whether this R is external force? No, it is internal force. कारण की बार तर आपला पूर्ण अख्खा आहे ना, फ्रॉम दिस लेफ्ट एंड टू राईट एंड. आपण जेव्हा त्या बारला कट करतो इमॅजिनरी, मग इथे जो सेक्शन आपला तयार होतो, दॅट सेक्शन इज ट्राइंग टू मेंटेन द इक्विलिब्रियम. मग ते कशाला मेंटेन करणार आहे? टू मेंटेन दिस एक्सटर्नल फोर्स P, this section will offer a resistance in opposite direction of this P. In similar way, now we have lower image in which right bar is highlighted or right side of the bar is highlighted. Now again, to balance this P which is acting to the right, this section or cut portion or cut section will try to maintain the equilibrium, and to maintain the equilibrium it will offer a resistance which is denoted by R but with opposite sign. Means P is acting to the right, so resistance will act to the left. Okay. So what is stress? It is internal resistance per unit cross sectional area. Internal resistance per unit cross sectional area. Remember Newton's third law. So in third law only force is involved, but in stress the load and its area is involved. So what is stress? It is internal resistance per unit cross sectional area. It is denoted by sigma, and its formula is resistance upon area. But whether we know the magnitude of resistance? No, because it is internal property. So whenever somebody asks you what is stress, you must say it is internal resistance per unit area. त्याचा फॉर्म्युला जर विचारला, ओरल मध्ये सांगतो पर्टिक्युलरली, फॉर्म्युला जर विचारला तर सांगायचं सिग्मा इक्वल टू R by A, means resistance upon area which is equal to P by A, because resistance आतमध्ये होणार आहे मेंबरच्या किंवा बॉडीच्या, आपल्याला आतलं मेजर करता येत नाही, बट वी नो फ्रॉम न्यूटन्स थर्ड लॉ देयर इज इक्वल अँड अपोजिट रिएक्शन, त्यामुळे जेवढा फोर्स असेल तेवढीच तुमची रिएक्शन असणार आहे. Therefore the resistance R is replaced by P force or force P, that is external force. Hence the formula stress is equal to sigma equal to P by A. हे समजलं एवढं? So this was about stress, and unit of stress is Newton per meter square. So moving to strain, so that we'll cover in tomorrow's session.